for our review today, we went over the categorical versus quantitative variables. A categorical variable has values that are usually words, such as names or labels, and quantitative variables are values that are usually numbers. An important thing to remember about quantitative is that it's something that's measurable and has a meaningful average. So phone numbers would not be a quantitative variable because an average phone number doesn't tell us anything. Okay, so not all numbers are quantitative variables. You got to kind of look at them and decide. One concept we didn't talk too much about that pops up now and again is discrete versus continuous. Discrete would be a whole number count, like you have one tennis shoe or you have two tennis shoes. You don't have any amount of tennis shoes in between. It's one or it's two. Continuous would be you could have 1 inch or you could have 2 inches, but you can have a whole bunch of values in between 1 inch and 2 inch because so values exist between the holes, and it can be infinite and go on kind of forever. The individuals, that's the objects described by the data, animals, people, things, those are all the individuals. When we did smelling Parkinson's, we were the individuals on the dot plot. The variable is a characteristic an individual can take. So during the smelling Parkinson's, the variable was how many shirts you guessed correctly out of the 12. And it was different for each person depending on their guesses. So it varied person to person. So here is a practice problem to kind of guess what are the individuals and what are the variables. Usually there's more of a setup, a little bit more of a story. But in looking this, the individuals, I see states, but I don't think it's talking about individual states because then they start talking about family members and age and gender. So really the individuals are 8 states residents. There's 8 people from 8 different states. Okay. And then for the variables, so each one of these people have variables. Okay, so our variables, we had the number of family members, which is quantitative, age, which is quantitative, the state, which is categorical, gender was categorical, marital status is categorical, total income was quantitative, and travel time to work was also quantitative. Okay, so hopefully you're able to identify those. Let's flip this over and let me remind you, when you are going to describe data, these are the 4 things I need you to talk about when you're describing a distribution. You want to talk about the shape. Now, most likely the only shapes we'll be talking about, the most common, are skewed right, skewed left, or symmetrical. You want to look and mention for any unusual features such as gaps in the data or outliers. Be sure not to call them an outlier unless you've checked the data with this it's a rule of thumb. It's not 100%, but it's what most people use to determine if there are outliers or not. So if you don't have the actual, you can only say there are potential outliers or there look to be outliers. But if you're going to say there's outliers, it's because you did this and you know for certain that they're outliers. Center, that would be mean or median. You would want to use the median if the data is skewed, and you want to use mean if the data is symmetric. The last one is variability. Spread could also be said, how spread out is the data. That's really kind of your range. And if your distribution is symmetrical, you want to use standard deviation. And if your distribution is skewed, you would want to use IQR because IQR is made up of medians, and medians are resistant to outliers. So in describing shape, there are several shapes here. I gave you a couple of extra ones. They might not be as common, but when you're describing, you want to pay attention to this. Symmetric, it's symmetric from the center. So if you drew a line right down the middle going out, it's symmetric. So even this bottom one is still symmetric. From the center of the graph going out, you have some symmetry. Skewed right is when the tail is on the right. The majority of the numbers are on the left and you have some on the right. And then skewed left is just the opposite. The majority of numbers on the right, but something happened to the left that pulled the curve over to the left, so it skewed it left. Unimodal means one peak. So when you draw a loose curve over your data, you have one peak. If we look at this one, I had 3 bars that were exactly the same height, but when I draw my curve over it, it is just one peak, so this is still unimodal. Okay. Bimodal means bi means 2 modes. That means if we had a loose curve over the top, it would go up and it would go down and back up again for 2 peaks, so that's bimodal. This one's not considered bimodal, even though there's 2 modes right there, because it's still only one peak. But if we look back over here at this guy, we go up, we go down, and go back up again. That's bimodal. Okay. And then the last one, it doesn't show up as often. Some people call it the butter graph because it kind of looks like a stick of butter that's been cut. The tops of the bars are all about the same. An example of this would be if you rolled a dice a whole bunch of times, like 1,000 times, the probability of each side occurring is about the same. So after a whole bunch of rolls, they'll all be about the same height. Okay. Also remember, when you're going to compare distributions, use LY words. Don't just list, actually make a comparison. Slightly skewed right, approximately symmetrical. You can be a little hedgy with your words. If you're going to say it is this, it needs to be whatever it is you're saying. So we like to use a little bit of the soft language here. And if you're going and comparing, you need to say what both or all 3 distributions are. Depending on how many you've got to compare, you need to include all of them, and with all 4 of those things from above: the shape, the unusual features, the center, and the variability. So your two-way table, you guys did really well on this on the Unit 1 practice. To find the marginal relative frequency, you would take a category total from the margin and divide by the overall total. To find a joint relative frequency, you find whatever it's asking for where the 2 categories cross and divide that by the overall total. And your conditional is a category joint number divided by a category total. So hopefully the colors maybe help you remember how to find those values. All right, then we did a segmented bar graph. So a couple things I want you to remember on segmented bar graphs is make sure you use a percentage for your scale. Do not use raw numbers. I want percentages. They should both, or however many bars you've got to draw, they should be 100% tall, because we use a conditional probability to determine the percentages in each category. Be sure when you set up you're looking for your percentages, set up your fractions. There needs to be some labeling. So I could have used colors and made a key. I used numbers. So I labeled these 1 through 5, and then I labeled these over here 1 through 5, and then we can make a comparison. You want to go in the same order on both, so it's easier to make the comparison. A question that could come from this, and is very likely to come from this, is there an association? If the graphs look different, like especially here is where they look different the most, yes, there's an association. Knowing the person is male can change what I know about their thoughts about getting rich. Okay, so there's an association. If the graphs are pretty much identical, then there is not an association. Okay, because you can't tell. It doesn't matter which one you pick, they're pretty much the same, so there's no association there. All right, our mean, remember a mean, the symbol is X bar. It means mean. Add up all your data values and divide by your total number of values. Your median is the middle number when you put everything in order. Resistant measures is your median and your IQR. They are called resistant because they can resist the pull from outliers and they don't move as far as, say, a mean would. And let me show you what I mean by that. So I have 3 drawings here. In a nice symmetric drawing, your mean, median, mode are approximately the same right down the center. If we have a skew left, the mode is still the tallest part of the peak, but the mean gets pulled further because of these lower numbers than the median does. So the mean was pulled much lower on a skewed left, so the mean is lower than the median in this case. On a skewed right, your mode is still the peak. Your mean gets pulled much farther to the skew than your median does. Median is still always in the middle. So in this case, your mean is a bigger number than your median. So you could see some numbers, and if they're about the same, you could say, oh, I think the distribution is symmetric. If the mean is smaller than the median, you say, oh, it could be skewed left. If the mean is bigger than the median, it could be skewed right. Okay, so it's just gives you kind of a heads up of what the distribution might look like if you cannot see it. And then on the back, we talked about range, which is your max minus your min, your median. So here I have 9 numbers. So the median would be this exact middle number, and that left me 4 on each side of it. To find the first quartile, it's the median of the lower half. So I had to find the exact middle of the lower half, which is actually between what these 2 numbers would be. To find the number, I would add these 2 numbers and divide by 2 to get the first quartile. Same with the third quartile, it's the median of the upper half. It's exactly between these 2 numbers, and so we just add those 2 numbers and divide by 2. I'm going to show you a calculator, how to do it on the calculator in just a second. Your interquartile range is Q3 minus Q1. It's a box on a box and whisker plot. It's resistant to outliers because it's made up of medians, and medians are resistant to outliers. Okay. To make a box and whisker plot, we need the 5-number summary. And the 5-number summary is your minimum, Q1, median, Q3, and your maximum. To find outliers, remember you want to use this rule of thumb, and it will tell you the lowest number that's not an outlier and the highest number that's not an outlier. Anything bigger than this number is an outlier. Anything smaller than this number is an outlier. So let me show you, the key is up, so you can go and pull this up whenever you need to take the chance. But let me show you on the calculator. If you do not have a calculator, you really need one for this class. If you have Android, you can download Wabbit Emu on your Android. It's free. If you have an Apple, there is TI-84 emulator, I believe it's called. It's $5. It will do some of the things for free, but it won't do everything we need to do for free. So, but a calculator is highly recommended. You're really going to need it for your AP exam in particular. So I'm going to show you how to put this in. I'm going to use Barry Bonds data here. All right, we'll go Stat, and it brings up this menu that says Edit, Calc, and Test. Right now we're just going to go into Edit. So we press Enter. I already have the data in here, but if this is not the data that you need, you would just up arrow until the L1 for list 1 is highlighted, and you'd press Clear and Enter. And then you could put each piece of data in, so you'd put the number, Enter, so it would shift down to the next line. Okay, so this is all Barry Bonds data. I'm going to go back to Stat. I've already edited the list. Everything's in there, so I'm going to arrow over 1 to Calc for Calculate. We're going to run a 1 variable statistic. So that's your option number 1 that's already highlighted. Press Enter. We put all of our data into list 1. If your data is in a different list, you can change that. And so to see down here on above the numbers, I have L1, L2, L3, L4, L5. Those are the list numbers, so I would have to press the second button and one of those, whichever one you put your list in. Okay, so I'm in list 1, leave the frequency lists alone. There shouldn't be anything there. And we're going to calculate. What I got provided I put all my numbers in correctly, is I have x bar equals 37. That means the mean is 37.